Hello, Professor Lam. Hello, Karen. This is my final report on Meanderpy. Sorry I could not be on Zoom meeting. I will be traveling internationally starting tomorrow, which is Wednesday. However, I'll be continuing this research to next term and to the SURF, so I can answer any questions or get any feedbacks based on this final presentation. So I have been using Meanderpy to predict Ucayali River in Peru. I wanted to see if I can predict the cutoffs that happens, and there is for Ucayali River in the region that I chose, there is cutoff in 1994 and 2006. So the problem was that the standard input parameter of Meanderpy predicted the 1994 cutoff, and in the image below you can see the navy colored shape is the actual river geometry, and the light wider colored sky geometry is the prediction. So you can see as the wider shape does cover the actual geometry of the 1994 river, and there was a cutoff right here. The river in 1993 or prior was flowing like that, and there was a cutoff right here, and Meanderpy did predict that. However, for 2006, there was river pass previously was flowing like that, but now there is a cutoff right here. However, the prediction does not cover it. You can see it rather goes towards the left, so it does not do the cutoff prediction. So my goal was to build a systemic method in which I can alarm which areas nearby the river is in danger due to either meandering or river cutoffs. And I knew I could not just use the standard model to predict that, because you can see it's not that reliable. So there is in Meanderpy a variable called CRDIS, which is the cutoff threshold distance, and basically in my knowledge this is how close the rivers have to be in which the cutoff begins to initiate. So the standard is 1,000 meters, and that predicted the 1994 river cutoff, but not the 2006 river cutoff. So I wanted to test 500, 1,000, 1,500, 2,000, and 2,500 meter variables for the threshold distance in which the cutoff occurs. Going back to the 1984, you can see that this is the river geometry, and right here, 1994, there's a cutoff right here. And so now these are the prediction outputs of the Meanderpy. So at 500 meter, it does not give any cutoff range. For 1,000, it predicts a cutoff right here. For 1,500, it predicts a cutoff here and here. For 2,000, it predicts a cutoff here, here, and I believe here. And so you can see the general pattern of increasing the cutoff threshold makes the predicted river much more linear, and that makes sense because it's adding more cutoffs to it because the sensitivity value is much higher. And this slide shows all the combined prediction output and the layer of the actual 1994 river channel geometry. Now you can see that the combined prediction geometry does cover all the land in which the river will affect by 1994, which is accurate and good. The idea of this, I was talking to Kieran last week, is similar to predicting floods. So not all the prediction zoned land will be affected by the river. However, I believe it's much better to have this a much larger sets of area in which the prediction does predict, because you never know. For example, I mean the example was 2006 because that did not predict the land in which the cutoff occurred. And now comes the 1993 to 2006 river, and you can see there is a cutoff right here in which the standard model did not predict. So here's and once again, they repeating the cycle, 500 meter cutoff threshold, 1000 meter, 1500 meters, 2000 meters, and 2500 meter cutoff threshold. You can once again see the general pattern of the prediction river getting much more linear compared to as the cutoff threshold gets higher. Now with the combined prediction, it does cover the cutoff threshold, in which having just the standard model did not cover. So this is a much, well, this isn't like a complete 100% accurate prediction river cutoff method. However, it does have a much wider range of prediction, which has a lot more land to predict. And that's both a positive thing and a negative thing, because it's not as accurate when it comes to like what exact land are affected. It gives a much broader, much wider range areas of land. However, the accuracy is much greater. So that is basically the model that I'm trying to maybe implement to the Arctic River permafrost prediction. Thank you for listening to this presentation. Let me know what I think, and I will be back after spring break. Thank you so much.